Hello, everybody. Welcome to our session about bite-sized microgrids. Byte with a Y because it's a video game theme. Anyway, I'm Dylan Lockwood. I'm senior editor at Zpryme. I've got a great panel of fellas here to talk about microgrids. I'm just going to go down the line and have you all introduce yourselves.
Yeah, thank you. My name is Jim Piotrowski. Been with APS for 40 years, a long time in a lot of different areas, and currently I'm responsible for all utility scale renewables, so batteries, wind, solar, and microgrids fits into that same portfolio, and so excited to be here to talk to you today.
Good afternoon. My name is Martyak. I'm Chief Sales Officer of PowerSecure. I was blessed to be one of the founders of PowerSecure 22 years ago, and we started doing microgrids before anybody knew what a microgrid was. And these guys happen to all be my customers, so I'm very blessed to be here today.
Hi, Dave Morton, Director of Microgrids, Edged Energy. Microgrids, data centers, high-tech, leading-edge development of a number of technologies, but our main focus is microgrids, and believe it or not, I've worked for all three of these guys at one time.
We took a picture of that last night when we were at dinner, so his three bosses behind him.
They don't like me to hang around long.
And good afternoon, everybody. Jason Smith. I'm the general manager at Bright Canyon Energy. We're actually a sister company to Arizona Public Service, where Jim Piotrowski sits, based in Phoenix, Arizona. But we develop energy infrastructure basically anywhere outside of the APS regulated footprint. So great to be here with everyone today. And looks like we got a relatively small group in the room here. So look forward to an engaged and interactive discussion here.
Great. So let's get into it. So when we're talking about microgrids from a utility perspective, what are some of the key issues utilities are looking at microgrids to help address?
So since I'm the regulated side of the utility, I'll take the first stab at it. But I mean, we've, like Mark said, we've been working with them for over 10 years, and we've seen a lot of different value from microgrids. From deferred upgrades on lines where we had a 21 kV line that we needed to upgrade. If we were going to go ahead and put in some microgrids at the end of that, it was a lot less money to put a microgrid in. So it just runs at the peak time in the afternoon in the summertime in Arizona. We've had partnerships with some key customers like Marine Corps Air Station, line data center where we have 12 megawatts there, 25 megawatts at that site. Key relationship for APS because we get to operate that when we need it, but they get it from a resiliency perspective, and we actually split the cost with them. So it's a good win-win value for them. So if there's key partners out there that you want to partner with, it works out really well from that perspective. We actually use it from a fire mitigation strategy. It's kind of interesting because, we have a lot of mountain territory. We've got over 36,000 miles of distribution line in Arizona, and a lot of it's up in the mountains. People don't think of pine trees in Arizona, but there's a lot of mountains there. So in the summertime, we actually, when the relays typically will try to reclose 3 times really fast. If you see some sort of fault on the system, we stop at 1 time. Well, now we physically have to drive those lines to make sure we're not going to start a fire when it re-engages. So we've put a couple small microgrids on some communities that it'll open up with an automatic transfer switch, and now we can actually keep those customers energized. So it helps our SAIDI-SAFI numbers as well. So it's a nice little solution, and it also we're getting close to the thermal issue on those lines as well. So it's a win-win situation. So there's some little niche strategies that they can work for as well. So. And then the last really, I think, is capacity. We've used those from a capacity perspective. We don't put them in for capacity, but we've definitely had to use them on the hottest part of the summer. We've run those before when there's an issue, back when it was in January when, Texas froze over, with the diversity fuel, and using diesel, there was a real shortage of natural gas at that time. So we were able to run both of those large microgrids at the same time to help that. And I think we ran them, 14 hours or something like that at that time. So we found a lot of little niches to be able to use that, and it's worked really well.
It's probably worth mentioning that you're talking about the hottest part of the summer in Phoenix, which is pretty intense.
120 plus sometimes. I mean, it's not unlike to hit 115 on a regular basis. I think last year was a record year of 110 days or above, and I don't remember exactly what the number, but it was a record day. I mean, it's getting hotter everywhere, so it's becoming more and more critical for us as a resiliency issue as well.
Well, God bless Jim.
And I just jump in with one other operational anecdote. There was an event where Palo Verde, it's the nuclear plant just west of Phoenix, tripped offline, and the microgrid at Marine Corps Air Station Yuma and Aligned Data Center, which are geographically dispersed, but they both saw the frequency disturbance in the system and kicked in and supported both the grid and their host customers. And because all of that's done autonomously, that happened in the system long before anybody in the operations center at APS actually dispatched the microgrid. So by the time the operations center personnel dispatched the capacity resources that Jim was talking about, the microgrids in both instances had already been online for 7-8 minutes before that control signal was sent. So the microgrids transitioned from a frequency response control signal to a capacity dispatch signal from the operations center, and then stayed on that signal until the operations center felt the system was stable, and then brought the microgrids offline. So I think it's a great example, and Dave can talk more about this if he wants to jump in too, of how these systems, once they're in place and you get more and more of them, they can actually act in concert, in tandem, to help bring more reliability to the grid.
And one more point, we design specific technology into these microgrids that we actually reserved. We got the third patent today, as a matter of fact, on it. They autonomously sit and watch the grid, and grid events occur up and down the West Coast. And I'll give you an example of frequency response. Say 1,000 megawatts goes off in Idaho, which it does. It literally shakes down the western seaboard with equal magnitude at the source as there is at the critical end. So what happens is this critical equipment will trip offline. Quite common in an F-35 fighter base, which is where Marine Corps Air Station Yuma is. The better example of that, picture a rock in your hand, you throw it in a pond, that's a frequency event, and the waves that come out, quite literally, is the frequency going down the line. Since we installed that system in February 2017, it has reacted approximately 260 times autonomously to the grid in grid events, protecting not only the base but supporting the grid. So the base itself, we were told, we've reduced the nuisance trips on the F-35 by 70% down there. So real mission enhancer in that case. Also, we've got a sister microgrid at a data center, level 3 data center. It literally does the same thing at the same time. So they work in unison hundreds of miles away, but it protects that data center as well. So it's very unique in that sense.
Yeah, it's probably worth noting that as utilities are gaining more and more of their portfolio with renewable assets, solar, wind, et cetera, those are intermittent sources. So what happens on your hottest day in Phoenix when it's 120 degrees and the sun goes behind a cloud? Well, that you see that effect up and down the California ISO with the amount of solar we have in California. So our advanced microgrids actually, as Dave said, react autonomously and instantly to those events. And what they really do is they become a non-spinning substitute for utility spinning reserve. And when folks talk about being zero carbon or carbon neutral, a lot of times they talk about that in terms of what's inside their fence. Hey, we got a big solar field, we got battery energy storage, we got some wind, but they don't look at the effect on the entire system. And a great case of this is Germany. If you want to Google Germany's energy woes, a whole host of things come up, because what Germany did is they were leading the world in solar deployments. But what they didn't do was have always ready generation, fast start, clean energy to replace that solar when it does go behind a cloud or when the wind stops blowing. And that's what these advanced microgrids do, and we really think they are the solution. And as we gain and gain, we all want more renewables, but you have to have that always ready, clean, fast start sources of energy to replace that. And that's what we do.
Yeah, and one more point, APS they're a balancing authority. Means they have to balance the power when the power goes up and down on the entire Western grid. That being said, there's a specification by NERC and FERC called BAL 003. They have to respond to events in a critical period of time. So what they traditionally do, they take an LM6000 turbine, big turbine, run it at 50% and wait for an event, because you don't know when they're going to happen. So that burns fuel, huge emissions, huge maintenance. They don't like to run at 50% to begin with. With these microgrids, because they act so fast, they shut them down. So they don't burn fuel, they don't have all the emissions, they don't have all the maintenance waiting for an event. These microgrids actually respond that quickly that they can do that. For example, Marine Corps Air Station Yuma's got 40 engines in there, Tier 4 final, cleaner than turbines, I will say, and they come up to full load in about 8.4 seconds from a dead stop. We do it at the, all right, it is. I was the one testing and doing all this. Anyway, another point, example, we do it with batteries and microgrid up at Aligned Data Center, so we come on sub-cycle time. So it can be done either way. It's a very interesting technology.
Yeah, so I'm very interested in these technologies that allow for it to be fast and to be autonomous in these ways. So, how is the changing technological landscape, and also just the changing perspectives of utilities and investors and vendors alike? How is that changing the concept of a microgrid, the way we think about it?
Well, traditionally we've used combustion type of machines, the diesel engines, turbines, things like that. Now we're incorporating things like fuel cells. We're incorporating solar, batteries, large systems for the military as well as industrial, commercial customers. And we're quite agnostic as to for the type of energy we're using. It doesn't really matter what we hook it up to. We can control it and diversify it throughout, throughout whatever the future holds for energy production.
Yeah, we've seen a lot of advancements in technology. I've been in this business for 43 years, and I've never seen the rapid advance that we have today. I really wanted to retire, but I'm too excited about what's going on to retire. So we're dealing with companies that are developing hydrogen-based microturbines that are much more efficient and much more stable than what we have today. Companies they're doing technologies that are taking plastic to fuel or plastic to electricity. So taking, the world is choking on plastic. So picture a barge in the middle of the Pacific Ocean hauling in one of these plastic islands and turning that into a renewable diesel fuel that can be burned much cleaner in machines, for instance. We are also working with a company that, and Dave can speak to this, a new technology called Grid Block, and it's an energy router that has multiple AC inputs and multiple DC outputs. That is really going to revolutionize, we think, the EV trucking industry, frankly. So we see tremendous advancements. And then the other thing that's really happening in the industry is you're seeing utilities want to interact with their customer at the meter. Not behind the meter, not ahead of the meter necessarily, but at the meter. Because these microgrids, that's where they need to go to have the major benefits. So if you think about data centers, hospitals, big pharma, they all need resiliency, right? So they're all going to have generators on site, or UPSs on site. Well, when you combine it with an advanced microgrid, the value of for instance, a UPS is batteries. The same battery energy storage system can also provide a customer uninterruptible power. Okay, the generators that somebody may have on site, like the dirty diesel generators, Tier 2, if you upgrade to Tier 4 final, now you have diesel burning cleaner than a utility peaking power plant. You combine that with solar and energy batteries, and you customize a system for each owner. So the owner's getting resiliency, the owner's getting substantial reduction in carbon, the utility's getting capacity, frequency control, and all those value buckets can come together to be extraordinary. And one thing I will say, with APS providing the system at Marine Corps Air Station, that was provided at zero cost to us as taxpayers because of the value that I just talked about.
And we'll take it one step further. We are the company that's developing plastic to fuel. We also take landfill gas to fuel, and we pull the carbon out in the form of graphene. So it's actually sequestered carbon that comes right out of the system. That fuel that comes out is ASTM quality diesel fuel that is completely carbon free. So it's interesting technology. We can use that with the microgrid as well and bring it together and have some real scales of economy and synergistic effect.
I just have a question. How many people are from a utility in here? So you understand. So there's a handful of you. So, if you've been there for a while, you remember when, we never had reverse power going through substations at all because everything was pushed out to the grid. That's the way we've always operated, we've always run. And, with the variability of the grid, and we've already covered that and the benefits of the microgrid, but what I really think is valuable as well is if you get an area that is an issue, these are small enough that you can actually put them in load pockets. So, our traditional generators, we typically put them outside of town. You're bringing everything in. They're not going to run that often, but when you do need them, they're there, and then they're within your load pocket. So it gives you a lot of different value from that perspective as well.
Yeah, another thing to add in, as far as changes go, what we see is our customers now, when they're, especially our data center customers, big pharma customers, when they're putting a facility from day one, you think about a microgrid and you say, okay, you got a facility, you got a campus, now we're going to add a microgrid. Well, everybody's now thinking from day one, they're looking at their buildings not just for what they're going to function as, but they're looking at them as a bi-directional microgrid from day one. And that's an important change in perspective, because just like Jim said, if you might have a bad load pocket. You got a data center company that comes in and they just bought that land. Now what you got a problem on top of a problem, right? Unless that data center is a bidirectional microgrid, then you add the load, high load factor load, utility loves it, and you have the capacity right there, the non-spinning substitute for spinning reserve, so you're helping out the utility all at the same time.
Yeah, we're working with TSMC. It's a Taiwanese microchip manufacturer. They're building almost a $20 billion facility right outside of Phoenix, and we're looking at the same type of partnership that we partnered with MCAST as well as the data center. So going in there partnering with the microgrids as we're talking. So to the point that Mark just said, we can use that as an asset. It's there for their resiliency, it's there for their backup, but it's a win-win. They're not having to put all the capital cost out. We'll work on a arrangement where more than likely, I don't want to say 50-50, but the numbers there, we'll figure that out. But then we take on the maintenance and we take on the operation side of that as well, and then it automatically responds. So it really, I hate to use the word win-win-win, but it is. I mean, everybody wins in this scenario because they're not funding the whole process, we're not funding it, and we all get to use it for what we need it for. So it's good for the customer base.
And we take it one step further also together. We build data centers, quite honestly, to incorporate them into microgrids is what we're doing right now. We're rolling out over 100 of them in the United States right now. And EV charging is a big deal. Companies like Amazon are buying fleets of vehicles, and they have no idea how to charge them. Our technology with grid block and data center design, small modular 5 megawatt data centers, we can go in, build the distribution, million square foot distribution facility, incorporate the backup power data center, and do all the EV charging across the board. And we do it very quickly because of our technology we use. We eliminate all the switch gear, we eliminate the transformers, we eliminate the inverters. It's a very, very compact design system. It's very interesting, and we take that and spin it around the entire data center concept with EV charging and microgrids. And it's a single package that really solves a lot of problems.
So one thing that came up when we were prepping that I wanted to give you an opportunity to speak on was someone brought up that one of the potential barriers to more advanced microgrids is that regulation is yet to catch up. Can you expand upon what that means and in what ways regulators could better be thinking about it?
Yeah, sure. So I think probably two things we need to work on in the regulation area. One is, if you think about microgrids, as Mark described, they're at the meter. And that's an important, from a regulation perspective, an important kind of point of demarcation, because everyone today basically thinks of in front of the meter or wholesale resources, and there's tariff and procedures for wholesale resources, and then there's behind the meter resources that face the customer. So everyone typically thinks, a resource is in one of those buckets, one of those two buckets, but not both. And that's the space that microgrids operate in. So as we're out there as a developer working with customers and finding, wholesale offtake, we are at the same time, facing our customer, the host customer who wants the microgrid energy resiliency benefit. But then under normal grid conditions, we're exporting the energy and capacity to the grid. And so we're operating under two different tariff regimes. And so we've had to spend a lot of time working with our interconnecting utilities to educate them on how that works, because that's not a normal operating mode that you find resources in. And so I think one of the regulation areas we need to work on reforming is how do we more streamline that so that we're not having to, in parallel, do both a behind the meter interconnection and then in front of the meter interconnection to enable the functionality of a shared resource like Mark was talking about earlier. So that's one area. And the second area I'd say is where regulation needs to catch up with technology is from a technology perspective. we have the capability now for the microgrids to basically have a seamless transition on the front end of a grid event and a seamless transition on the back end of a grid event, such that the customer, hospital, military installation, airport, literally wouldn't know the difference of who was serving them, whether it was their host utility or the microgrid itself. But with the way the regulation works right now and the switching that needs to occur and the protocols that need to occur with interconnecting utility, oftentimes there's a multiple second gap on the front end at best before we can pick up the service from a microgrid perspective, even though autonomously we could be ride through on the front end of the event and the customer not ever notice it. So those are, I think, the two areas that as we're out there working on developing microgrids that we face as big challenges and trying to get adoption and development done that we need to work on from a regulatory perspective.
And we've gone into Southern California Edison, and they've seen our technology, and they've looked at us and honestly said, this is exactly what we need, but we have no idea how to tariff it. We've never seen anything like this. We just don't know. And so there's no clear path, we're making one now, but it's difficult and arduous, to say the least, to understand the technology and then to incorporate it within a tariff or a metering standpoint.
And I'm just going to add, those of you that work for utility, we're not easy to work for. I was at the EV thing earlier, and they had the utilities on this side and the developers on this side, and said, those are you bad utility people. But the fact is, we get in the way of ourselves. We've got engineers that have been around for 20, 30 years. They're set in their ways. And, we've got a couple of the large microgrids. We've got, as small as, under 2 megawatts, and some of those other ones I'm talking about, 5 megawatts, kind of scattered around. But we are still struggling internally, and we've got these up and running, but trying to get our own internal people to understand how to operate these. And, we've got all the protections built into these systems, but then they want these other layer of protections on top. So we as utilities, and if you're working out there, if you're a developer, we're still trying to figure it out. I think the regulation on the big picture Jason's talking about is really, really important, but we need to figure it out internally. We're struggling internally with our own folks, and sometimes working with our own T&D group. I sit in our generation group, and it's more challenging than working with you guys or somebody else than internally. And it's sad, but it's just the truth. So I think there's a lot of growing that has to happen in all this interconnect space.
And I can absolutely vouch for that. I was with APS, to say the least. And quite honestly, when we brought up the idea of a microgrid at an Air Force or a Marine Corps Air Station, the people, senior leaders inside of APS, they just left. They said, we don't want anything to do with it. It's a career killer. It'll never work. So quite literally, they gave me a credit card. I went to Yuma. They said, don't come back till it's built. And we built it, literally with very little interaction of the utility itself. But it's proven itself over 5 years now. It's the Pentagon refers to it as the platinum microgrid solution. It's a wonderful thing. But now trying to replicate it again, they're going, lots of people involved now because, it's a success, so they want to be involved. But they think of it as like a giant steam turbine or a giant gas turbine, and it's not. It's a completely different animal, and you can't use those same rules. So it's difficult. I don't work for them anymore, but.
Yeah. And I'll throw something in there. So we have 2,100 plus active microgrids around the United States, parallel behind over 300 utilities. And I know you would think, it's not possible. We do a lot in the cooperative public power world. Like we're behind all 52 electricities in North Carolina, for instance. So that adds up pretty quick. But large IOUs, small munis, everyone. And the one thing I wish could happen is we still see within utilities, everybody still looks at microgrid. I shouldn't say everybody, but there's still a big percentage that look at it like this, like it's still an experiment, right? We got it, and each utility is kind of learning on their own. But let me tell you, there is just a world of data out there, and we've been doing this when we founded the company back in 2000. We started doing microgrids before anybody knew what they were. So we've got, and all of our data, by the way, goes to a company called M Technology on a real-time basis. And what M Technology is actually a branch of MIT, and they calculate the reliability of our microgrids. And the head of, and this is a quote from him, Stephen Fairfax, he's kind of the reliability guru to the Goldman Sachs and the Googles and the Amazons and everybody. And he says our microgrids are 2.5 times less likely to fail than any other power supply in the United States, which we're very, very proud of. But my point is, with utilities, I wish there was a way to get, kind of that joint learning together. so that everybody could see what the reliability is. We've learned our lessons. We publish all that data. So we're not, when we make a mistake, we're not kicking it under the carpet, hiding it. It's out there for everybody to see. And so as far as the education goes and bringing utilities together on the regulatory side, I think that would be really helpful.
Awesome. Well, so I've got some more granular questions we can maybe get to, but first I just wanted to see if we have any audience questions. I see one right in the back there.
So I don't know, 2 years ago, I don't think we would have a conference like this, before COVID, without hearing the word, not cyber, not crypto technology, but what's the other word?
Cybersecurity?
Huh?
Cybersecurity?
Not cybersecurity.
Blockchain.
Blockchain. Blockchain. So here you guys talk about microgrid, but I'm talking about blockchain. What happened to blockchain? Is blockchain going to be part of the solution going forward? Is part of security?
Well, I mean, the security that we have to follow is NERC, FERC, SIP security protocols. I mean, that's up to them. When they start bringing that in at that level, then obviously we conform to it.
But is blockchain part of the solution? I mean, I don't know if I really understand blockchain, but I understand that the technology behind it allows you to keep track of every piece of it in a distributed way. So if this part goes down, you still are able to maintain.
We do that within our control system right now. I wouldn't.
Not blockchain.
No. It's a very sophisticated control system, to say the least. Like I said, we've got 3 patents on it. Third one issued today. Good work, guys. And so it's amazing what we do, and we data log literally from the beginning of time for this thing, and we can see everything that's happened within it. And it's got numerous redundant systems that work. I'll be a little geeky here. We have a CAN bus system that operates. We got microcontrollers, over 60 of them in there probably, roughly, and they all communicate with each other without a central host over a fiber optic network within this thing, a double redundant fiber optic network. So it's a very fast, very speedy machine that is constantly communicating, but without blockchain.
Not blockchain. Just all connected to all different parts.
Correct.
Yeah, the part of blockchain that we are, so the blockchain verification, I mean, that's all coming, and it's very highly power intense, right? So we got to figure out a way that all this can happen. Just like with EV charging, when this comes in, we're going to have tremendous capacity needs that we're going to have to address. Blockchain's one of them. And so we're working with blockchain companies to develop data centers that are highly efficient, very low PUE, and then combining with the utility, because one good thing about blockchain is it's not like a regular data center where if it goes down, that's bad. Blockchain can go down, and then when power comes back up, you can just keep on going. So we're working to put together algorithms and AI to be able to integrate all that, and it's coming in.
Is it coming city by city? Are we going to see one smart Austin before we see a smart Seattle, before we see a smart Colorado?
I can't answer that question. You'd have to ask the city leaders there, but I don't know the answer to that question.
We got a question right here.
Twofold question. First, what's the approximate megawatt per square footage or per square yard, whatever it might be, for the microgrid? And the second, yesterday there was a presentation on this virtual peak plant, which kind of I think serves the same purpose, as if I'm understanding correctly, as a microgrid. Can you use a microgrid in that capacity? Because you said fast, reliable generation. So
Sure.
Why are we not using it if it's already employed at what is it, 5,200 or whatever?
Well, I mean, to answer your first question, we have 25 megawatts in less than an acre. So pretty compact, dense system. Yeah, it is. It's pretty amazing. But like I said, we use multiple engines, and the reason we do that is redundancy. One engine goes down, the rest run. One controller goes down, the rest run. One power block, which is 4 engines in this case, goes down, the rest run. We have redundancy throughout this thing. So it's very resilient in that fact.
Yeah, and they are used as a non-spinning substitute for spinning reserve, like I said. So if APS, they are shutting down natural gas-fired peaking plants. We have utilities in the Northeast that are shutting down old coal plants and replacing with our microgrids. Yeah, absolutely.
And it does change a little bit customer to customer too, because if you're using, think about the diesel gen sets or batteries, those are small footprint, right? We have one customer that we're working with where we're going to develop 100 acres of solar attached to the microgrid as well. And so that's going to take up a lot more space, but we're able to, the great part about that system is we're going to be able to use solar, charge the batteries, and then only run the gen sets to back up when you need to serve the load at the customer we're working with.
Do you another? Sorry, I'm not The virtual peak, we're just wondering, what's your thoughts on it? Would you think this?
Oh no,
is
another piece. See, you know how everybody talks about like the panacea of renewables, solar and wind. We got to do solar and wind. That has a major part, right? Virtual power plants have a major part. What you got to understand about is we have hard assets on the ground that serve as that physical hedge against, high cost times and high peaking power times, and so it's really physical equipment versus, virtually buying energy or moving energy, from point A to point B, right?
And you got to remember that when you get solar and wind, that's great stuff, but you're taking inertia out of the system. There's no spinning weight. A big generator is a big spinning weight, and when a change in the system happens, it works like a shock absorber. It's hard to slow it down. It's hard to speed it up. It stabilizes the system. Shut down all those plants, you lose that. Hawaii is a great example. Oahu. Frequency goes all over the place over there because they just cloud comes by, something goes off, load comes on, and it goes up and down all over the place. They're trying to deal with it, and it's a very difficult thing to deal with.
You guys saw it here in Texas a couple years ago, right? And then the past few summers with what they're going through in California with PSPS, and you can see where if you count too much on it, the reliability and resiliency go out the window. So you got to bring it all together.
We had a frequency event. The wind honestly quit blowing in West Texas. It stopped, and the whole grid reacted to it. I mean, the frequency dropped, everything went. All kinds of power plants started coming up all over the place to try and compensate for it. It was very interesting, and we follow these events. We see them. We understand where it comes from, but it's very fluctuating, to say the least, with the renewable energy.
Yeah, we've got about 100 megawatts of microgrids in Oklahoma, and they actually firm wind. So a lot of the Oklahoma utilities are buying wind out of North Texas. But when it's 110 degrees in Oklahoma City, you know why? Because the wind's not blowing in North Texas. And so on peak days, they only get about 5% of that capacity of wind that they purchase. So our microgrids firm up that wind, and they run them during those times.
That's all part of the ecosystem. Thank you for the question. We had one over here.
I know you touched on this several times throughout the conversation. Hopefully we understand a little more specifically. But you talked about microgrids sort of in the sense of using them as like a non-wire solution or like peak demand management use cases. So there's like a cost avoidance associated with that. And I also assume that there's some type of like capitalized infrastructure that you install. But how do you monetize these as the utility outside of sort of those niche cases? Is there a way to operationally monetize it? Absolutely.
You go.
Jim.
You want me to start?
No, so in 2,100 sites across the country, and they are all what we do is we say our microgrids are at the crossroads of resiliency and zero carbon, okay, and every one of them is commercially viable. We don't have one installation that was subsidized by the government. We partner large energy users with their utilities, and these different value buckets. Frequency control in the California ISO has a lot of value. Capacity has a lot of value. Building new transmission, new substations, putting them in load pockets so you don't have to do that. That's all the value on the utility side. And plus reducing carbon. Our customers, who are big pharma, big healthcare systems, et cetera, they need the resiliency. They need the uninterrupted power. They also now they used to pay lip service to the carbon reduction, but now they're actually wanting it and actually doing it and measuring it. And I can tell you right now, we're working with a big pharma player that you would instantly recognize the name of, and we're taking them in the Northeast from an on-site cogen system, not because for economic reasons were they cogenning, it was because of power quality reasons that they wanted to actually control their power. We're moving them from that to a new microgrid that's got uninterruptible power supply, solar, battery energy storage, and our EPA Tier 4 final super clean diesel generation powered by a renewable diesel fuel. And we reduced their electric costs from 11.2 cents per kilowatt hour to 6.2 cents per kilowatt hour. So the project paid for itself, and we reduced carbon day one by 26%. So I hope that helps. That's just one example.
Yeah. So I'll try to answer your question. So I mean, Our substation group right now, every upgrade that we go through, we look at alternatives besides just adding more wires. So we're looking at batteries, we're looking at microgrids, we're looking at different solutions. So that analysis happens. If it makes good business sense for us to do that, then we can recover that through a normal rate case that you would with the utility. So we build the case, we make sure that it's the right solution for that circumstance. And there's a lot of times it's not, but if it is the right solution, then we'll actually recover that right through a normal rate case recovery.
And I'll bring that back one step. I mean, we talk about frequency response. When they're running an LM6000 or 2 or 3, depending on how many, waiting for an event to occur, that's a lot of money. If you have a machine that just sits there, doesn't have to run until it autonomously sees it and fires up, that's a huge savings. Not only it's a huge savings in fuel, maintenance, and emissions. It's massive. I mean, that's a huge number for a utility.
Thank you. We got in the back corner.
You talk a lot about the data center as one of your targets. Have you worked with any like these carbon-free data center initiatives where they're trying to provide carbon-free data center, or any of these initiatives where they're trying to have a DC power data center?
Absolutely. Our technology, grid block technology, it centers on that DC technology. It operates at 18,000 kilohertz, or 18 kilohertz, 18,000 cycles. What does that mean? It brings in power and chops it in little tiny pieces of energy. That energy is not AC or DC, it's just energy. Recirculates it either to the DC side or reforms it on the AC side. So it eliminates a tremendous amount of equipment for one thing, but secondly, it can supply DC and or AC around those sides of things. Now, that's huge in the form of carbon reduction, obviously, but when we incorporate our plastics to fuel, waste to fuel as well, which is a decarbonized fuel, you've hit a zero carbon emission system at that point in time.
Thank you. Yeah, we got one right here.
So data centers, it's not uncommon, above 50 megawatts. In fact, there's discussion of hundreds of megawatts, mega data centers. I mean, is there an upper limit on microgrids to where it's no longer a feasible approach?
It depends on, the question is, the higher you go, what source of energy are you going to use? Are you going to use small engines? That'd be a lot of small engines. You use bigger engines, you're going to use different technologies. So we start using different technologies in that sense. Batteries are a big deal nowadays. The data centers traditionally have used inverters. They take all the power off the grid, run it through inverter 24/7. We don't do that. We use a cold UPS. So because our batteries are able to come on so quickly, we're able to run clean power off the grid, not manufactured sine waves, 6 pulse, 12 pulse, 18 pulse, and run it into the data center. When there is a disruption, we can come on with batteries sub-cycle time. You won't even notice it. Batteries come up, wait for the generators to come up, and then the batteries go off. Generators take over. So that's a huge savings, huge savings. The battery side of it is much smaller at that point in time. The power going to the data center is much cleaner off the grid because it's not manufactured. And it saves everybody, including the data center. So you can get much bigger by scaling in those areas.
Yeah, the other thing we see a lot of when you get to that scale, it's often more economic to build a backup data center than to try to build redundancy into that one, right? So you have two, and you put them in two different locations, so they're not subject to the same hurricane or tornado or earthquake, and one data center backs up the other, and because there is a limit to it.
We build upwards of 100 megawatt data centers right now. So it's common, but like I said, we do it very uniquely, much different than anybody else. And obviously Google and all the big players out there are very, very interested, and we're doing a lot of work with those people.
So do you see a DC residential community?
Well, I actually did see one. We haven't done that. Our approach to residential neighborhoods, and you can look this project up, it was called the Neighborhood of the Future. And instead of everybody having, battery wall in their garage and a little generator from Home Depot around back and all that stuff, we back up an entire neighborhood. And the Neighborhood of the Future was 400 kW of natural gas-fired generation, about 800 kW of solar, and a battery energy storage system that backed up the entire neighborhood. So and this is exciting too for, we all want to be green, right? But if you live in where there's lower income, et cetera, And people just can't, they don't have the homeowners associations that can afford that kind of thing. This is a way to do it, or they can't personally afford to put solar on their roofs, or this is a way to do it much more efficiently, much more cost effectively, and back up an entire neighborhood. So a little bit of a different concept, but I actually spoke on a panel not too long ago with a company that's doing the DC neighborhoods. Interesting concept, and like I said, there's no one solution. You know, all the pieces, parts come together to make us all better.
Yeah, and on the Air Force side, they do have DC sections of bases, absolutely, because of the type of equipment they work on. They have literally DC microgrids inside of them, and we're working with them using our technology, and really not only eliminating a lot of equipment and a lot of overhead for them, but doing it much more efficiently.
We have time for one more, if someone has one. Nope, then I'll ask one. How do you address some of the interoperability challenges when you're combining all these different technologies?
Back to Dave.
That's me, huh? And we do. We have many platforms that talk to each other. I mentioned it before. We have a CAN bus system. We generally take those platforms and we'll run them into a system known as a data concentrator that spits out one common language, if you will, and we control it through a common language. Probably the easiest way to say it.
Yeah, and let me approach that more generally. So what we encourage our utility partners to do is to take a holistic look at this. We provide microgrids on a turnkey design, build, own, operate basis. And what we still see folks doing is putting out a spec and buying this person's battery energy storage, this person's generator, this person's solar system, this person's inverter. Then they hire an integrator. Well, to try to put it all together. And we've seen that approach fail time and time again. So I would say if you're really interested in a microgrid, go with, it doesn't have to be us, but with a firm that does it on a design build basis, one throat to choke, one back to pat, and then you can take the science experiment out of the microgrid, right?
Totally agree.
Awesome. All right. Well, Jason, David, Mark, Jim, it was a pleasure having you on to talk about microgrids. And thank you all for joining the conference. Feel free to talk with any of us at the networking break. And we hope you enjoy the rest of the conference. Thank you.
Thanks, everybody.